Assalamualaikum everyone. In today's lecture, we are discussing the causes of instability in our drugs and what is their prevention. There are two major causes which are playing an important role to make our drugs unstable. So these two causes are, first of all, is hydrolysis and then is oxidation. A lot of drugs that we are using get oxidized and get hydrolyzed, so therefore they will become inactive or unstable. So now we are discussing in this lecture the first main cause of instability of drugs, which is hydrolysis. So hydrolysis, as the name indicate, hydro mean water and the lysis mean breakdown, mean that the something is breaking down in the presence of water. In some types of drugs, the water is used to prepare them, that we see that the liquid dosage forms and various kinds of syrups and the are preparing in presence of water. So what will happen in these drugs, the water get ionized, and due to this ionization of water the drug become unstable because they react with the ions which are produced by the ionization of water, and the drug become inactive. The drugs which contain water in them are syrups, emulsions, and the suspensions. Now the drugs are affected by the traces of moisture. We see that in our air a lot of water vapors and the moisture and humidity is present. So if we are exposing our drug to the normal air, or we are exposing our drug to high temperature, then we see our drug become inactive. So it is very important to control all the conditions around our drug to make it more effective. Now, due to moisturizer, actually what happened, various hydrolytic reactions occur in that drug and make it ineffective. Now we see actually hydrolysis is also benefit for us and also have some disadvantages. The great benefit of hydrolysis is that it is used to give us energy, because it convert our ADP into the ATP, which is the energy yielding compound. Okay, and the biggest disadvantages of hydrolysis that we see, how we have antibiotic penicillin. When this penicillin exposed to moisture, what happened? The chemical breakdown occur in that drug, and this drug will become inactive. So it is really important to maintain or to keep penicillin drug in moisture controlled conditions. Now we are discussing the types of hydrolysis. We have two types of hydrolysis, ionic and the molecular hydro. As the name indicates, ionic hydrolysis means some ions are producing. Okay, we are using the salt of any weak acid and the weak base. We say that weak acids are very good donor, and the weak bases cannot accept. So therefore, when they react with water, what will happen? The solution which is formed, this solution can be acidic in condition of weak acid and can be basic in presence of weak base. So this ionic hydrolyze the salt and make it acidic or basic. It occurs in drugs that contain an alkyl group. Okay, these alkyl groups react with water to form ions, and then they completely dissolve in water. As we say, the ionization of water and the ions which are producing by these groups means salt of weak acid and weak base. Actually, these ions react with each other and they become soluble with each other, and the drug will become inactive. Now we have molecular hydrolysis. We see a lot of molecules which are present in our drug can be hydrolyzed by water, but it is really slow and really irreversible process. ठीक है, क्योंकि because in this type of hydrolysis a large molecule has to break up. ठीक है, the formation of ions is quite easy. Okay, but to break a molecule is very difficult, so therefore this process is very slow and irreversible. We have a molecule here which is codeine phosphate, and when we add water into it, it becomes a acidic solution. Now, when this acidic environment is given to any drug and then it exposed to water, then what will happen? This drug break. For example, local anesthetics drugs. ठीक है, they have if we are giving acidic environment to that drug, and then this acidic drug then exposed to our moisture, then what will happen? this drug break, and the local anesthetics will have no effect on our body. So we are discuss the types of hydrolysis. Now we are discussing another classification of hydrolysis, and this classification based on our drug gradation, that how a drug it degrades. First of all, we have three types of hydrolysis, this that is ester, amide, and ring hydrolysis. Okay, what are the main classes of drug that undergo hydrolysis? Actually, why we are discussing only ester, amide, and ring hydrolysis? Because the ester and amide groups and the electron groups, these groups are main cause of hydrolysis, mean they are more reactive toward the water. As the moisture exposed to that drug, they become unstable. So therefore, what will happen? First of all, we have ester hydrolysis, and it is most common type, in which what acyl and oxygen cleavage is occur. Okay, what will happen? Actually, this is our ester, this is our ester group. Actually, what will happen? Acyl and the oxygen cleavage is occur. This is our acyl group, and the this cleavage is occur between our oxygen and the acyl group. So therefore it can be called as acyl oxygen cleavage. And what will happen in this type of reaction? Our ester is converted into alcoholic and the carboxylic acid. Okay, when they expose to the water and we add acid catalyst into it, what will happen? This acid catalyst, actually this R group is released, and this R group attached with the water OH, and this H take place of R. Okay, then we say R C double bond O, OH is formed, which is carboxylic acid, and the alcoholic group is formed. Okay, and now we discuss the example of drugs that undergo ester hydrolysis. Okay, we have four drugs which are undergoing our ester hydrolysis, that are aspirin, procan, tetracycline, and atropine. Okay, now what is the mnemonics to revise them or to memorize these drugs? We have a short word which is pathan. We see that in our today's areas, today in आजकल we have see that Pathan song is very trending. So we see the mnemonics Pathan to learn these four drugs which are undergoing ester hydrolysis. First of all, Pathan P. P means procaine, A for aspirin, T for tetracycline, and then again A, which means atropine. So the word Pathan will help you to learn these drugs. So what? Pathan, P for procaine, A for aspirin, T for tetracycline, and A for atropine. Now we discuss the second type of hydrolysis, which is amide hydrolysis. What we see, it means that these drugs contain amide group in their formulation, and then this amide group, it will become cleave and then break down, and they form various products. What kind of products is formed? Actually, the products formed by this amide hydrolysis is carboxylic acid and our amine group. There is great difference between the amide and the amine group. Okay, this is our amide group, in which NH is connected with the RC double bond O group. Okay, then this group means the amide group, when exposed to water and small heat which act as catalyst, what will happen? It will convert it into the carboxylic acid, because this cleavage occur. Okay, and this group attack on the OH of the water, and this group what will happen, take one hydrogen from water and become NH2, or this group is called as amine, because it has no carboxy group or carboxyl group in it. So therefore there is difference between the formula and the structure of amide and amine. Okay, so you have to really focus on it. Now we have the examples of drugs which contain amide group and which can undergo amide hydrolysis. We have mnemonics here. What? बाबरा निकल गई है चोर का दिल लेकर. Okay, so this mnemonic will help you to learn all these four drugs which contain amide group. So what means by Barbara? Barbara is a girl and which means barbiturates. This barbiturates acid is a acid and it is discovered by a girl which also named as a Barbara. And this Barbara girls also called by his family as Barbie. So you have to learn that Barbara, a girl, which means which discover barbiturates. Nickel. निकल मीन्स नियासिनामाइड. ठीक है, नियासिनामाइड. निकल गए है चोर. चोर मीन चोरा पिनाल. Okay, का दिल. दिल means डी ब्यूकेन. Okay, now you have to learn this. बारबरा निकल गई है चोर का दिल लेकर. बारबरा means barbiturate. निकल mean niacinamide. Chor mean chora phenyl and dil mean D-bucane. So these four groups which four drugs which contain amide group in it. Now we discuss the third type of hydrolysis which is ring hydrolysis. Means these are the drugs which contain a ring-like structure in them. And what will happen? The water ions mean hydrogen and hydroxyl ions attack on that ring, and the ring expansion or the ring opening reaction will occur in this type of hydrolysis. And the drugs which are undergoing this type of hydrolysis are benzodiazepine, penicillin, and the chlorobenzodiazepoxide. So you have to only learn just these three drugs. First of all, we have penicillin, benzodiazepine, and the chlorobenzoperoxide. So we see our penicillin is unstable because what happened? Ring hydrolysis actually occur in it, and we have discussed in this lecture that the penicillin can undergo breakdown reaction. So it is actually ring hydrolysis mean when exposed to water, its ring open. Now, as example, we discuss lactose hydrolysis. This is the structure of our lactose. Okay, this oxygen attack on that hydrogen and this ring will open. These groups are not present, so not focus on it. Just this structure is, and this ring is open due to the reaction, due to the exposure to it with water. Now we discuss how we protect our drugs against this hydrolysis process, because it is very important to save our penicillin. It is very important to save our niacinamide because it is really important chemical, and a lot of girls are using niacinamide today because it is really good for skin. And aspirin and a lot of important drugs are present which are destroying just because of hydrolysis. So we can't see them to unstable due to the hydrolysis. So we have to protect these important drugs. So first of all, we have solid drugs, means the drug which are present in our solid dosage form. So how to prevent them to undergo hydrolysis? What we use silica gel bags. These silica gel bag has moist resistance and we have to prepare them in humidity control conditions. Now the other we have hydrolysis in liquid dosage form. In liquid dosage form, the chances of hydrolysis are more because in liquid dosage form we are using liquid as a solvent. So what we protect them, we use several things. First of all, we have to add any buffering agent into it. This buffering agent catalyze the catalyst which can be acid and base in that direction, and we get the optimum pH. Now we should add minimum amount of buffering, because if we add a lot amount of buffering agent into it, then what will happen, this buffering component can promote hydrolysis. So therefore we should keep the concentration of buffer minimum and to maintain the pH. Now we see that hydrolysis occur when we use a watery solvent. So if we replace this watery solvent by a non-aqueous solvent, then we can save our drug from hydrolysis, and we suppress that portion that in which hydrolysis can occur. We can add surfactant into it. This surfactant make a oily layer over that drug and prevent from the hydrolysis. Then you can convert your drug into the powder form. For example, penicillin is converted into the dry powder and then prevented by hydrolysis. And refrigerating is very important for the afferents drug, means CAC 100 plus drug. So if you refrigerate them, then they prevent from hydrolysis. Use of hydrolysis is to get energy, food, sulfication, mean soap production, explosive, paper, biofuels, synthesis of chemical, pesticide, and insecticide. So that's all today's lecture. Allah Hafiz.